Okay, so there we have chapter 9, model-based decision making, optimization, and multi-criteria systems. In this chapter, we will talk about several important things, like when you will take a decision and you have several criteria. For example, we are working in a company and we have a position, one position, and we have many applications for this position. Okay? So how you will choose from these applications? How you can determine the best candidate for this position? So this is what we call the multi-criteria decision making. The multi-criteria decision making. لأنه when you will hire someone, you will consider several things. Like what? Tell me. You will consider what before hiring someone in a new job, in a new position? You will look for what? يلا جاوبوني. الخبرات السابقة. نعم. His experience. What else? Yes. Good answer. What else? الشهادات. Yes. What is his major? That's it. يا بنات شاركوا، يعني سؤال كان بسيط جدا. When you will hire someone in your company and you have several candidates, عدة متقدمين لهذا الشغل. So there is several criteria when you will select the right candidate. So what are these criteria? حنان قالت الخبرات السابقة والشهادات. That's it. That's all. النظر إلى أخلاقيات، المهارات, skills, experience. حسب نوع الوظيفة. Maybe we will need languages, how many languages he speak, how many years he have experience, he's graduated from which school. So all of these criteria, المشاريع التي سبق نفذها. طيب مثلا we have 5 candidates from SEU منكم انتم من الكلاس بتاعكم. there is 5 candidates وكلكم عندكم نفس الشهادة. So we will look for other criteria, your experience, your age, the languages that you speak, etc. Expositions, yeah. Okay, so and this is a very complicated. This is a very complicated process when you will take a decision based on several criteria. Okay, so the learning objectives of this chapter is to understand the basic concepts of analytical decision modeling. Okay, let's put the slide in full screen. So the learning objectives of this chapter is to understand the basic concepts of analytical decision making. Describe how perspective models interact with data and the user. Understand some different well-known model classes. And understand how to structure decision making with the few alternatives. Sometimes you have few alternatives and you will choose from these alternatives. Describe how spreadsheets can be used for analytical modeling and solutions. Explain the basic concepts of optimization and when to use them. Optimization يعني you have several solutions and you will select the best solution. This is what we mean by optimization. Okay. Describe how to structure a linear programming model. Describe how to handle multiple goals. Explain what is meant by sensitivity analysis, what if analysis, and goal seeking. And describe the key issues of multi-criteria decision making. Opening vignette. Question for opening vignettes. Okay, decision support systems modeling. Decision support system modeling, what we mean by optimization and simulation, contribute to organizational success. Example include. Have here some examples. So in decision support system modeling, we are trying to optimize and simulate the reality. Major modeling issues, problem identification and environmental analysis. So when you want to take a decision, you have to analyze your environment. And you have to determine also the variable that you have in your domain. So, like influence diagrams, cognitive maps, etc. Forecasting and predicting. More information leads to better prediction. Multiple models and model management. Here you have the categories of models for the decision making. There is the optimization of problems with few alternatives. There is optimization via algorithm. There is optimization via an analytic formula. There is the simulation, heuristics, predictive models, and other models. Let's say, for example, the heuristics. The process and objective of heuristics is to find a good enough solution using some rules. And for the representative techniques, there is heuristic programming, expert systems, etc., etc. Model categories: static and dynamic models. For the static analysis, single snapshot of the situation, single interval, steady state. And it's a static analysis, everything is stable, nothing is dynamic, nothing is changing, everything is stable. على عكس dynamic analysis, we have a dynamic model that will change based on the data that you have, evaluate scenarios that change over time, time dependent, represent trends and patterns over time, more realistic, extend static model. Let me give you an example. When you want to go from your home to your university, you have a specific path. مثلا لو ساكن مثلا في حي الشاطئ وجاي على الجامعة في حي فيصلية. The best thing is to go through Shari مثلا. But this is if everything is static. If everything is static يعني ما في تغير في الترافيك جام، ما في تغير في توقيت الريد لايت. I would take this route. But in a dynamic situation, we will have a traffic jam. So maybe we can take another path. Maybe we go to the universities through Saud al-Faisal, for example, which will be much more better to save time. So this is dynamic analysis. Application case. Okay. Model categories, cueing trends in modeling. Development of models and solution libraries like Nails Server for optimization and resources link at informs.org. And there is the web-based modeling. There is the multidimensional analysis and influence diagrams. Structure of mathematical models for decision support. They are non-competitive models, and for the competitive models, mathematically link decision variables and controllable variables and result variables. The components of models. Here you have example of component of models like the financial investment, the decision variables in the financial investment alternatives and amounts. The result variables is the total profit, the risk, the rate of return on investment, earning per share, liquidity level. All of these are some variables as a result, and uncontrollable variables and parameters like inflation rate, prime rate, competition. So here it's an example of a model, financial investment, where you can find several decisions. Okay, and this decision is based on the profit, based on the risk, based on the liquidity level, etc. And here you have several areas like marketing, manufacturing, accounting, transportation, and services. Let's take another example. In transportation, for example, the decision variable is the shipment schedule and use of smart cards. So, for example, we have a company that have buses going from Jeddah to Mecca and Mecca to Jeddah, for example. So we need to determine a scheduling for these cars, for these buses. جدول أوقات، جدول مواعيد هذه الحافلات. فبالتالي to determine this schedule, you need several parameters like for example the number of passengers, and as a variable, result variables, like you have the total transport cost, the payment flow time, and for you have some variables that are uncontrollable, like the delivery distance and the regulations, maybe the weather. The weather will change the timetable of your company. Okay, here some examples. Okay, when you want to optimize a problem, usually you design a mathematical model. So the structure of a mathematical model. The components of a quantitative model are linked together by mathematical expressions and equations or inequalities. For example, the profit. What is the profit? The profit is the revenue minus the cost. Okay? The profit equals the revenue. كل الفلوس اللي حصلتها نقص منها التكلفة. You will have the profit. So this is a mathematical expression that will help to in your model to determine the benefit and the profit. And here you have another example. Simple present value. Modeling and decision making under certainty, uncertainty, and risk. Okay. غالبا لما الديسيجن ميكر ياخذ القرار he's in a specific environment. This environment ممكن يكون فيه risk. ممكن there is uncertainty and maybe there is certainty. So القرار اللي راح ياخذه هو يعني is based on these factors. The certainty where you assume complete knowledge. All potential outcomes are known and may yield optimal solution. For the uncertainty, there is several outcomes for each decision. The probability of each outcome is unknown. The knowledge would lead to less uncertainty. And for the risk analysis, which is probabilistic decision making, probability of each of several outcomes occurring. The level of uncertainty leads to the risk, the expected value. Look to this picture, the zones of decision making. Okay, here you have the risk in the middle. In the left side, you have the certainty, and in the right side, you have the uncertainty. When you are uncertain, that means you are ignorant. You are ignorant. So here you have ignorance, total uncertainty. يعني مثلا طالع من البيت الساعة 7 الصباح ورايح العمل وما اعرف لا شفت نشرة الأخبار ولا الطقس ولا حالة الطرقات. I am ignorant. I don't know when I will arrive, if I will take this road, and if I take the other roads, when I will arrive. So this is the uncertainty. But if you know everything, you will be in the certainty side. If you have the complete knowledge of the traffic jam, of the weather, of the everything, so if you know everything, you will be in the certainty side. If you are in the middle, you are in the risk. Okay? لو نقصت الcertainty وزادت uncertainty, you are in the risk. So لو زادت uncertainty ونقصت uncertainty, so we are increasing the knowledge. ولو نقصت الcertainty وزادت uncertainty, we are decreasing the knowledge. Okay? This is what's called the zones of decision making. Application case. Okay. Decision modeling with spreadsheets. So there is several tools that may help you in decision making, like the spreadsheet, Excel, most popular end user modeling tool, flexible and easy to use. Here we are talking about the Excel, by the way, where you will find powerful functions, programmability. You can program some macros in Excel. You can use the what-if analysis and goal setting, simple database management, seamless integration of model and data, incorporates both static and dynamic models. As example, the Microsoft Excel, that is 1, 2, 3. Application case. Here you have an Excel spreadsheet with a static model example, simple loan calculation of monthly payment. يعني في ورقة الإكسل هذه we are computing the monthly payment the loan calculation of monthly payment. The loan amount 150,000, interest rate 8%, number of years 30, number of months 360 شهر, interest rate per month 0.67%, and this is resulting E7 divided by 12. When E7, this is E7 8% divided على 12 مقسوم على 12. وهذه 360 هي E8 multiplied by 12, and this is E8 number of years multiplied by 12. So in this Excel we can compute the monthly payment for a specific loan. So at the end we determine the monthly loan payment. So if you take $150,000, you have to pay per month 1,100. 1,100.65. This is a static model. Here you have a dynamic model. Example, simple loan calculation of monthly payments and effects of prepayments. أضفنا هنا prepayment. So if you add the prepayment, your monthly payments will be changing. So this is dynamic model. Optimization via mathematical programming. Mathematical programming, what's the meaning? It's a family of tools designed to help solve managerial problems in which the decision maker must allocate scarce resources among competing activities to optimize a measurable goal. The optimization solution is the best possible solution to a modeled problem. And the well-known linear programming is a mathematical model for the optimal solution of resource allocation problems. All the relationships are linear. عدة تفاصيل رياضية في في linear programming. Linear programming problem characteristics. Limited quantity of economic resources. Resources are used in the production of products or services. There is two or more ways to use the resources. Each activity is returned in terms of the goal. Allocation is usually restricted by constraints. The linear programming step. You may identify the decision variables, the objective function coefficients, the constraints, like the capacities, demands, etc. And then you will represent the model using a specific software like the Lindo or the Excel. Lindo, which is a program where you can write a mathematical formulation. And in Excel, you will input the data into specific cells, and then you will run the model and observe the result. Here you have an example of a linear programming model. So the product mixed linear programming model. The decision variables that you have are how many computers to build next month. This is the problem of the company. How many computers we will build next month? There is two types of mainframe computers, CC7 and CC8. And this company تصنع نوعين من الكمبيوترات CC7 and CC8. والسؤال هو كم من كمبيوتر سوف ننتج الشهر القادم. The constraint. ما هي the constraints that you have in your company? There is the labor limits, materials limits, and marketing floor limits. So the labor day is 300 for CC7, 500 for CC8. Have to be less or equal to 200,000. The materials, 10,000 for CC7, for CC8, 15,000 have to be less or equal to 8 million. For the unit, 1 CC7 have to be greater or equal to 100, and for CC8, 1 CC8 have to be greater or equal to 200. The profits of 1 CC7 is 8,000, and for 1 CC8 is 12,000, and this is to maximize. So we need to maximize the profit. So the objective is to maximize the total profit per month. So this is a mathematical programming. This is a linear programming. Linear mathematical programming. LP solution, linear programming solution, with algebraic formulations. So here the decision variables are x1 and x2. x1 is the unit of CC7 to construct, and x2 is the number of units of CC8 to construct. Then the mathematical relationship, we need to maximize the profit subject to several constraints. And here you have the constraints that you write here. 300x1 plus 500x2 have to be less or equal to 200,000. The second constraint, 10,000x1 plus 15,000x2 have to be less or equal than 8 million. And finally, x1 have to be greater or equal to 100, and x2 have to be greater or equal to 200. So the result variable is z, which is the total of profit. Z equal 8,000x1 plus 12,000x2. Yani, to maximize the profit in the next month, we have to produce 8,000 units of CC7, and 12,000 units of CC8. And this problem could be solved using Excel. Okay, so in this Excel sheet, we are writing all the details of this mathematical programming, illustrating the power of spreadsheet modeling. Okay, I will go the details. Common optimization models. product mix problems. How many of each product to produce for maximum profit? The transportation, minimize cost of shipments. Assignment, best matching of objectives. Investment, maximizing rate of return. Network optimization models for planning and scaling. Replacement, capital budgeting. So كل هذه هي أهداف مختلفة ممكن نلاقيها في mathematical programming. Multiple goals, sensitivity analysis, what if analysis, and goal seeking. So if you have several goals, this will be coded differently. So if you have multiple goals, there is the simple goals versus multiple goals. Vast majority of managerial problems has multiple goals to achieve. Yani, for example, in a company, okay, the goal is to maximize the profit, but also the goal is to maximize the satisfaction of your customer, the satisfaction of your employee. يعني okay, ما تعمل مرابيح جمة على حساب الworkers of your company. ما تيجي على حسابهم هم. So this is another objective, which is the satisfaction of your worker. So vast majority of managerial problems has multiple goals to achieve, attaining simultaneous goals. The methods of handling multiple goals, you have the utility net theory, the goal programming, and the expression of goals as constraints using linear programming, and the point systems. Certain difficulties may arise when analyzing multiple goals. So certain difficulties may arise when analyzing multiple goals, like difficult to obtain a single organizational goal. The importance of goals change over time. For example, the goal of the profit is more important than the satisfaction, and then the objective of satisfaction is more important than the profit. So it depends with the situation of your company. Difficult to obtain a single organizational goal. The importance of goals change over time. Goals and sub-goals are viewed differently. Goals change in response to other changes. Dynamics of groups of decision makers, assessing the importance. So you have to rank your goals. Which one is the first goal? Which one is the second goal, etc. For the sensitivity analysis, it is the process of assessing the impact of change in inputs and outputs. This will help to eliminate variables, revise model to eliminate too large sensitivities, adding details about sensitive variables or scenarios, obtain better estimates of sensitive variables, alter a real-world system to reduce sensitivities, etc. This can be automatic or trial and error. So sensitivity analysis, you can do a test and see the result, etc. For the what-if analysis, assess the solutions based on changes in variables or assumptions. What if we change our capacity at the mining station by 40%? What would be the impact? What will happen? What will happen if we do this? Okay, so it's based on scenario analysis. For the goal seeking, it's backward approach. Start with the goal and determine values of input needs. يعني in this approach you start by the goal. Okay, حابب اوصل مثلا الى profit $1000 في الشهر في اليوم. $1000 في اليوم. خلينا نرجع ورا. اوكي لتحقيق هذا المبلغ لازم نرجع ورا. ممكن لازم نقول هذا الشيء هذا الشيء هذا الشيء. This is the backward approach. Example is break-even point determination. In order to break-even profit equals 0, how many products do we have to sell each month? Decision tables, the tabular representation of the decision situation alternatives. نعم أحلام تفضلي. أحلام, you want to say something? طيب أوكي, دقيقة بس. Okay. Okay, here you have an example of investment. The goal is to maximize the yield after 1 year. This depends on the status of the economy, solid growth, stagnation, or inflation. This is the situation of the economy. It could be solid growth, stagnation, or inflation. The decision table. If solid growth in the economy, bonds yields 20%, stocks 15%, and time deposit 6.5%. If stagnation, bond yield 6%, stocks 3%, and time deposit 6.5%. And if inflation, the bonds yield 3%, stocks lose 2%, and time deposit yield 6.5%. So this is capitulated in a tabular representation. Okay, payoff decision variable are the alternatives, and controllable variables are the states of economy. So the state of the economy is uncontrollable variable, and the result variable is the projected yield. So here is the alternatives, the bonds, the stocks, and the CDs. In solid growth, here you have the value. In stagnation, here you have the values, and in inflation, here you have the value. Investment example. The treating uncertainty. There is the optimistic approach, the pessimistic approach, and treating risk uncertainty. Use known probabilities and expected values. optimistic يعني المتفائل, pessimistic يعني الغير متفائل. So here with multiple goals, yield, safety, and liquidity. So you have for the safety, for example, high, low, very high for each alternative, and for the liquidity is high, high, high for the three alternatives. The decision tree, which is something that we know already, it's a graphical representation of relationships. There is multiple criteria approach. Demonstrate complex relationships. Cumbersome if many alternatives exist. Tools include mind tools, mindtools.com, triage.com, and palisade.com. You have an example of a decision tree. So, for example, this is a decision tree to take a decision. Would we sleep more or less? Sign up. طلعت الشمس, if yes, what day it is. If it is Sunday, sleep 2 more hours. If it is weekday, time to get up. If it is Saturday, today, sleep 1 more hour. If no, if the sun is not up, go back to sleep. So this is an example of decision tree. The multi-criteria decision making with pairwise comparisons. So when you have a multi-criteria decision making, مثلا if you will hire someone, and you will consider several criteria, you will compare بالاثنين يعني تاخذ two candidates تقارن الخبرة بتاعهم، لما تاخذ two candidates تقارن الخبرة بتاعهم، وكل مقارنة عندها value. So having more than one criterion makes decision making process complicated. Usually, some type of weighting algorithms is used to analyze such problem. The analytic hierarchy process, AHP, which is a very well-known algorithm to tackle multi-criteria decision problem. It's developed by Thomas Saati, and it's a very popular technique for multi-criteria decision making. And there is several popular tools like expert choice that use this AHP, the analytical hierarchy process. Another web-based tool which is hyper.al2.fi. And I advise you to read this application case that will give you a very good idea of the application of the AHP. Using AHP for selecting IT projects. So the problem is to select IT projects, and there is several criteria to select the project. So we will use the AHP method, analytic hierarchy process. I strongly advise you to read this case study. Okay, here you have a tutorial of applying AHP using Hyper website. So the goal is to select the most appropriate movie, for example. Okay? So here we have an example of selecting a movie. So you will identify some criteria for making this decision. يعني يا بنات لما تختاروا فيلم, if you want to see a film, you have 5 films. Which film you will choose? كلهم يعني عندهم جوائز, كل الأفلام عندها جوائز وأفلام ممتازة. So which film you will choose to see tonight? كيف تأخذون هذا القرار؟ يلا بسرعة باقي دقيقتين. I hope that I don't explain this to myself. كيف تأخذون القرار depends on the actors. Okay, this is one criteria, the actors. What else? Rate type. Okay, the rate of the film. Good. The time. النوع. نعم. The story. هل هو أكشن هل هو كوميدي؟ أوكي. طيب هم كلهم أفلام ممتازة. ف you will do some evaluation. For example, between film 1 and film 2. Film 1 is comedy. Film 2 is action. So let's compare these two criteria for these two films. Okay, let's continue to see the example. So here to compare films, we are considering the genre. نوع الفيلم, is it action, comedy, science fiction, romance? Language, is it English, is it Hindi, is it Arabic? Day of release, is it weekly, weekend? And user critics ratings, is it high, average, low? The rate of the two. The alternatives are the following current movies: Skyfall, The Dark Knight Rises, The Dictator, The Bank, Alien, and DDL. You have these films. So, step 1, define the goal, criteria, and alternatives. What is the goal? What are the criteria, and what are the alternatives? Okay, so here are the alternatives. Here is the goal. And here we will compare these criteria: the genre, the rating, the release date, and the language. Step 2, the main criteria are then ranked as they related to the goal. A comparative ranking scale from 1 to 9 with ascending order for importance is used. The ranking is done using pairwise comparison. يعني تاخذ بالاثنين بالاثنين وتقارنهم. Pairwise comparison procedure between any two criteria for all combinations of two. The tool weirdly normalizes the ranking for each of the main criteria over one another to a scale ranging from 0 to 1 and then calculates the raw averages to arrive at an overall importance rating ranging from 0 to 1. يعني الريتنج عملية المقارنة بين فيلمين regarding one criteria is a value between 0 and 1. Okay, this is using Web Hyper. This is the screen of this software. Step 3, all of the sub-criteria related to each of the main criteria are then ranked with the relative importance over one another. Step 4, each alternative is ranked with respect to all the sub-criteria that are linked with the alternatives in a similar fashion using the relative scale 0 to 9. Then the overall importance of each alternative is calculated. Step 5, the final results are obtained from the composite priority analysis involving all the sub-criteria and main criteria. وأنصحكم لقراءة الكيس ستادي اللي موجودة في الكتاب regarding the AHP. Okay, the screens. This is the end of the chapter. Is there any question? Okay, I will take the attendance. If you hear your name, raise your hand, please.